All right, what's up? It's Hutch here, and we're on Module 9, Lesson 2. I'm going to try to really keep this simple for you. I find it a little bit silly. This phrase here, well, that's a little bit too big. This phrase here, relative frequency, you're playing Blocko, so that's why it was really big. This phrase relative frequency really is the same thing as experimental probability. You're going to see it's the same numbers. I don't care what anyone says. They're basically the same thing. The big thing I want you to hold on to is the fact that we have a theoretical probability. And theoretical probability is what should happen, okay, based on just the math. Okay, experimental probability is what the probability is based on the actual experiment or data you collected. Okay, now when we're looking at the data, okay, so this one's like this fruit star data or whatever it is. Okay, could be any of these here. These favorite animal exhibit tallies and things like that, you can see we have a frequency, okay, in our data. And so that's where they get the term relative frequency. All they mean is write the frequency as a fraction, meaning the part you're focusing on divided by the total possibilities. And so that's all that is. I'll give you some good examples as we go so you can really see how closely related they are. It's sort of silly that we even use the two words. But anyway, so you can see here a relative frequency is the ratio. So it's just a fraction of number of favorable outcomes, meaning the thing you're paying attention to, divided by the total number of outcomes. Okay, it's just a fraction. Okay, no big deal. Okay, so anyway, we have this person named Lewis, and he has a bag of fruit stars, gummies or whatever, randomly selects a star, records its flavor, and returns it to the bag, and repeats that process 80 times. So based on his results, what is the relative frequency of selecting a strawberry star? Okay, so the theoretical probability would be you actually counting up how many watermelon, how many strawberry, how many mango there are, and dividing by the total amount, and that creates a probability of pulling watermelon, strawberry, or mango. Okay, experimental probability is run the experiment and use that data to determine probability. Okay, and so that's what we're doing here. Notice I'm using the phrase experimental probability, even though we're talking about relative frequency. It's because they're basically the same thing. Okay, so we have a number. This number of how many times we pulled it is also called, I want you to write down, the frequency. It's how many times you pulled it, how frequent, right? So the relative frequency means, well, what's the frequency relative to the total number of outcomes? Okay, so all you do is you would just take 25 and you would divide it by the total number of outcomes, which was 80. Okay, because we pulled 80 times. And then you would do 36 divided by 80, and you would do 19 divided by 80. Okay, and so we end up with this relative frequency, which can also be represented as a decimal and as a percent. Okay, so that's what we're going to get into as we continue on down here. So let's take a look. It says step 1, write a ratio. We already did that. Okay, so it's a part to whole ratio, number of strawberries to total fruit stars drawn. And so we already have that. I'm going to go ahead and put equals here. And let's go ahead and, oops, not 25 though, strawberries 36. So we have 36 over 80, okay? All right, now simplify the ratio by finding an equivalent ratio. We could, if we're not sure, we could divide by 2 over 2, right? And we would get, what's half of 36? 18. Half of 80 is 40. And then we could divide by 2 over 2 again, right? And we would get 9/20ths. And that's it, right? We can't simplify that anymore, okay? So we have that simplified down. we found an equivalent ratio. Write the relative frequency as a fraction, decimal, and a percent. So let's go ahead and write it as a fraction, 9/20ths. Let's go ahead and pull up our Desmos or regular calculator or whatever you're wanting to use. And let me go big version here. We'll do 9 divided by 20. Okay, and you can see as a decimal, so let's put equals, it is 0.45. Put equals again, and as a percent, remember we're multiplying by 100 or swooping 2 spots to the right, which gives us 45%. Okay, so there's a 45% chance of pulling a strawberry based on the experimental data. Okay, all right, so we have a 45% relative frequency. Guess what? That's also the experimental probability. So the experimental probability of pulling a strawberry is 45%. Same answer. That's why I find them silly. But anyway, all right, relative frequencies. Here we go. Example 1, a number cube with sides labeled 1, 2, 3, 4, 5, 6. So a normal number cube rolled 20 times. And the number 5 is rolled 4 times. Okay. So what they mean by that is we rolled a number 5 4 times out of the 20 times that we rolled. Okay, so there's the fraction. So let's go ahead and put that down here actually. So 4 out of 20. We want to simplify the ratio. Okay, so we can go ahead and divide by 4 over 4 to simplify that. And we end up with 1, and then 5 times 4 is 20, okay? And so we end up with 1/5. And then write the relative frequency as fraction, decimal, percent. So we write our 1/5. We know 1/5 is 0.2. It's a common fraction that we should be getting familiar with. And then 2 swoops to the right puts us at 20%, okay? And there we go. So there's your relative frequency. Notice we don't write it like the probability of rolling a 5. Okay. This is how you would write the experimental probability, and we're not doing that. We're just listing the relative frequency, but they're the same numbers. Remember, that's why it's a little silly. All right, go ahead and pause and try this one. It says a spinner with equal size sections, they're letting know it's fair, labeled A, B, C, D, E, F is spun 24 times. So that's your denominator. A vowel is spun 9 times. What is the relative frequency of spinning a vowel? Okay, so go ahead and set up your fraction. Okay, and then you can simplify the fraction. So let's go ahead and try dividing by 3 over 3. You can also, if you want, okay, I'm going to clear this. You could just do 9 divided by 24 and then change the decimal to a fraction there and see that it would just be 3/8. Okay, so if you want to just simplify it using Desmos, that's fine too. But we do have to go ahead and change it to a decimal, which is 0.375, and then turn it to a percent. And so we have 37.5%. Okay, and that's all you need. That's the relative frequency. Okay, so it's the frequency that something would be expected to happen. All right. Let's go ahead and take a look at example 2. So now you have a table here or a tally chart. We have a group of students went on a field trip to the zoo. This frequency table shows the results of the survey about their favorite exhibits. What is the relative frequency? So just think in your head, hey, what is the fraction changed to a decimal and a percent based on this experimental data? Okay. All right. So it says favorite exhibit being either penguins or bears. Don't get too tricked up by this word. It just means if you see penguins or bears, we need to include both of them. Okay, so step 1, so that we can have our denominator, is we need to find the total number of students surveyed. Okay, and then we need to find out how many people chose penguins or bears. So we have our numerator. Okay, so let's go ahead and add those up. So grab Desmos here, trusty Desmos, 6 plus 17 plus 21, if you actually type 21, plus 13 plus 13, and we get 70 students. How many chose penguins or bears. We have 6 chose bears and 13 chose penguins. So 6 plus 13. So 19 chose either penguins or bears. Okay, you could also use the word or. So you can see we already have the fraction down below, 19 over 70. So the relative frequency is 19/70ths, about 20.27, or swoop swoop. What percent is it? Yeah, 27%. There you go, done. All right, you can see, so not too bad here. All right, students at junior high were asked the question, what is your favorite activity at school? The results are shown in the table. Do you think that's true? Football is the most? Basketball, band? Oh, no, volleyball, second place, maybe. So what's your favorite activity? According to the results, what is the relative frequency of a student's favorite activity being either, so I want to make this stand out, track or football. So we're looking at track and we're looking at football. Okay. So express the ratio as fraction, decimal, and percent, round to the nearest hundredth. So pay attention to that as well. All right. So let's get the part we're focusing on, our numerator, which is 21 and 4. So if we add those together, obviously we have 25. What are the total amount for the denominator? So we unfortunately have to add all those up. So we already know we're at 25. Let's add the rest. Plus 13, plus 17, plus 7, plus 13. And we get out of 75. Now we know we need to simplify that. So let's go ahead and in Desmos, we can just do 25 divided by 75. And we get 0.3 repeating, or 1/3. So this simplifies down to 1/3. And we know that is 0.3 repeating. Okay. And as a percentage, swoop, swoop, we get 33 0.10ths hundredths with the 3 repeating percent. Okay, so it said round to the nearest hundredth, so that's why we had to go that far. So be careful, you don't want to get it wrong because you messed up the rounding at the end. That would be so sad. All right, let's go ahead and look at example 3. Looking at graphs to determine the frequencies. Okay, so let's go ahead and take a look. Find the relative frequency of spinning green or blue. So we're including green and the blue. Okay, so if we look and go straight across there, it looks like green is 24, and I'm just going to label it right on there and down below in the table. Blue, it looks like what, maybe 22 there? Okay, just want to be really careful. Find the relative frequency by writing the ratio. So same thing, we write it as a fraction, decimal, and a percent, and that is called the relative frequency because it is the frequency of our experimental data. Okay. All right, so let's go ahead and get our total of green and blue. 24 plus 22, 24, 34, 44, 45, 46. So we have 46 out of 46 plus 14, 56, and we end up with out of 60. So let's go ahead and just put that into Desmos, 46 divided by 60, and we get 23/30ths. Okay, which as a decimal, we can click that button again. We get 0.76 with the 6 repeating. Okay, and swoop, swoop, and we have 76. It doesn't have us round, so I just want to make sure all my numbers are correct. Yep, 46 plus 14, now 60. Okay, all my numbers are good. So we have the 1/3, or sorry, we have our 23/30ths, or 0.76 with the 6 repeating. It doesn't say to round anywhere, so we're going to have to go ahead and do our 76.6 repeating percent. Okay, and there we go. There's our relative frequencies. So let's go ahead and try it out here with the check. Okay, so a good time to pause and try it out on your own. What is your favorite household pet? We just need to focus on what's the relative frequency that we're looking at, and it says students' favorite animals being a dog or a cat. So we're looking at dog and cat, expresses a percent rounded to the nearest tenth. Okay, so we just need to do percent, but we might as well go fraction to decimal to percent anyway. So let's look at dog and cat only. So that's your numerator, the part we're focusing on. So 12, 22, 23. So we have 23 out of, what's the total? So let's see, 23 plus 6 plus 5 plus 6, and we got out of 40. Okay. Step 1 is to simplify. Technically, you wouldn't need to because we could just go ahead and write 23 divided by 40. It's automatically going to give us the decimal, so we don't really need to be simplifying it. 575, and then turn it to a percent, 2 swoops to the right, and so we have 57.5, and it does say stop at the 10th, which I did. So there you go, relative frequencies, done. Okay, all right, there's a whole bunch more on this, holy moly. All right, relative frequency tables and bar graphs. So they're just getting a little bit more complicated as we go here, but still very doable. So we have 100 randomly selected people. This is our denominator. Okay, it's out. Because remember, if we look way up at the top, your relative frequency is your thing you're focusing on out of the total number of outcomes. Okay, all right, so let's go ahead and take a look at this one here. Here's the blood types of 100 people. To find the relative frequency ratio, find the ratio of the number of people for each blood type compared to the total number of people surveyed, which is 100. And so you can see we already have all those fractions listed there. Okay, you can see that we can also list the frequencies and relative frequencies in a chart, okay, to just make it easy. You can also graph the relative frequencies. And so they're just having you see this in case this is how they represent them. So let's go ahead and do this. We have blood type A, and we came up with blood type A's relative frequency is 0.4 or 40%. So we can just go up to 0.4. So the easiest way to do this is to make the bar at the 0.4, then go down. I'll make my straight line and go down with my straight line. There we go. Okay. Now let's go ahead and do B, which is 0.1 or 1/10. So I'm going to make my bar at that spot and then go straight down and straight down. Okay, let's do blood type AB, which is 0.05, so just be careful about that. And then O is 0.45, and that's our highest one. That's actually what I am, is type O. And there we go. Okay, so you can represent those. You just have to understand that those are the relative frequencies. So you can see this one is a very low frequency to occur. This one is the highest frequency to occur, or the highest experimental probability as well. Okay, because again, they're pretty much the same thing. So this is a visual representation. Okay, so let's go ahead and take a look at experimental probability from relative frequency. Like I said, same thing. The only difference is you're going to see this actual event listed in front of it because this is all about predicting the future based on that data, okay, rather than just listing the ratio. Okay, but basically it's the same thing. Okay, you can even see here they have a chart telling you the similarities and difference. The similarity is they look the same. The differences are this one is just relative frequency is describing what already occurred, and experimental probability is predicting the future event. But look, they're the same number. It really isn't much different again. All right, so example 4, finding experimental probabilities. So again, they want you to find the experimental probability based on the relative frequency of someone having type A or type B. Okay, so we go ahead and add those up. So we have type A plus type B, and A was 0.4, B was 0.1 or 0.10, so they have the same place values. And so obviously we have 0.5 or 0.50, okay? So the experimental probability has the same ratio as the relative frequency. Like I said, they are the same, okay? So it says, so the experimental probability that a randomly chosen donor will have type A or type B blood is 0.5 or swoop, 50%. Okay, there's a 50% chance. All right, so let's go ahead and try this. You can pause if you want and check it out and then see how you do. So what was the last gift you received was the question that was asked, and the results are shown in this relative frequency bar graph. So they're asking you, what is the experimental probability that an adult chosen at random will receive a card or clothes? So what I'd want you to do, though, is for this, now that we're talking experimental probability, is we should put a P, which means probability of, and then for the event, we say card or close. And there's a symbol for that, but we're going to go ahead and just say that for right now. And then we put equals. And this is where you list that experimental probability, okay, with an actual event listed in front of it. So let's see where card and close are right here and here. And let's go ahead and add up those for our numerator. So we have 0.4. And let's see close here. It's a little hard to see on here. 0.25. 0.26, 0.27, 0.28. So 0.28 it looks like. 0.28. So let's go ahead and add those up. So we have 0.4 plus 0.28, and we have 0.68 is my focus. Out of the grand total, okay, and so actually, so here's what's different about those. Because it is listing the experimental because it's listing the relative frequency already, this is the percentage of those. So it's sort of like they already gave you this. So imagine this written differently. There's a 40% chance of getting a card. There's a swoop 28% chance. So if you add those up, what is the total percent chance? Well, we add those up and we have 68%. Okay, so we have 0.68 or swoop 68%. So I guess you experiencing that right now tells you that if they're asking you the experimental probability and they're already giving you the relative frequency, it's not going to be a numerator divided by a total, okay? But sometimes you're going to have to calculate that if they don't give you the relative frequency already. All right, so let's go ahead and take a look at example 5, estimate to make predictions. So if you are familiar with baseball, you know that there's a lot of statistics and data with hitting and catching and fielding and things like that. So in baseball, a player's batting average is found by writing the ratio of hits to total at-bats and then writing that ratio as a decimal. So that's how they record that. The player with the highest career batting average in history had 4,189 hits in 11,434 at-bats. Okay, so based on his relative frequency, how many hits can be expected in a season if that player has 500 total at-bats? So first of all, we don't know the relative frequency, which is just that ratio, right? So number of hits divided by the number of at-bats. So let's go ahead and write that down first. 4,189 divided by the 11,434. If I could write a 4. Okay, so let's write what that is as a decimal. 4,189 divided by 11,434. Okay, so there's the decimal we get. Okay, is 0.3663363, and then let's just stop there for right now. Okay. Now let's go ahead and turn it into a percentage, swoop. Okay, so we have 36.6, and then let's go to here and round 64%. Okay, now Typically, they would just keep it as a decimal, okay? But we're just writing it as a fraction as well. So let's go ahead and use that relative frequency to make a prediction now, okay? And we want to predict the number of hits for 500 at-bats, okay? So this decimal that we calculated, okay, that would be per bat. That's his chance of hitting, okay? So that's per one bat. So if we go ahead and we create a proportion, right? When we want to predict things, we make a proportion. So we have our 0.36663. We'll just go to there again. Per one bat. Okay, this is hits, right? And we set it equivalent to what we're trying to predict. So we want to know 500 bats, and we want to know what the amount of hits would be, okay? But they said let H represent the number of hits, so let's go ahead and change that X to an H, and then remember we can go ahead and multiply top and bottom by 500 over 500, or you can cross multiply, okay? Both ways will work. Okay, it doesn't matter which way you want to do. Okay, cross multiplying will always work for us. This one's a quick one though because we have a unit rate. We can go ahead and just multiply 500 over 500. Okay, and then create that equivalent fraction. Okay, so let's go ahead and do that now. Actually, we can go ahead and take answer. Oops, nope, back up. Enter answer times 500, and there we go. Okay, so the amount of hits for 500 bats should be 183, and we can't really have part of a hit, okay? So we would have approximately 183 hits for 500, and let's go ahead and write at bats, okay? All right, so there we go. Okay, there's our answer right there. All right, let's go ahead and do this check together. It says, over the past 5 years, it rained on 1/5 of the days in April. How many days can you expect it to rain in the upcoming April if the weather is expected to be consistent with the past 5 years? Okay, so they're giving us your experimental data, which is 1 out of 5. Okay, let's go ahead and create that relative frequency by making a decimal, right? So that's how we'll be able to do our work. So 1 divided by 5 is 0.2. Okay, so there's our relative frequency. We could write it as a percentage too, but let's keep it as a decimal since we know that we're going to be doing some proportion work. Okay, so it says in the next month of April, okay, how many days would you expect it to rain? So let's go ahead and look at the calendar. And let's go ahead to April here, March, April, okay? All right, and we can see that there are 30 days in April, okay? So here's what we know, okay? We know that it rained in 1 out of the 5 days, okay? So you could keep that ratio, or we can say 0.2 for 1 day, and set it equal to what you want to predict. So we're using that relative frequency to help us determine a future amount. So what did we say? 30 days. Okay, so how many times would we predict it to rain? Again, you can just multiply by 30 over 30, or you can cross multiply. Let's go ahead and I'll do R for my variable for rain. This time I'll go ahead and cross multiply so we have an example of both. Okay, we always do the variable first. So I have R equals, and then we can just do 30 times 0.2, and we get 6. Okay, and so there we go, R equals 6. Okay, and that's 6 days of rain. So how many days can you expect it to rain? 6 days. Okay, and there you go. Okay, all right. Let's head down to these applies. So now we're really kicking it up a notch. Same ideas, just a little bit more to do. Okay, so last year a DVD store sold 670 action DVDs, a certain amount of comedy, drama, blah, 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 blah. The store owner makes $3.31 profit on each DVD sold. So that's its unit rate, remember, per DVD. And expect to sell 5,000 DVDs this year. Okay, based on last year's results, how much profit can she expect to make just on comedy DVDs for this year? So let's look at the comedy DVDs. And so it says 560 comedy. So when they collected that data, let's get a relative frequency for this experimental data. So we had 580 out of how many total DVDs? Okay, well, we don't know how many total DVDs last year, so we unfortunately have to add those all up. So 650 plus the 580 in comedy, plus the 450 in drama, plus the 300 science. So that was out of 2,000 DVDs sold. Okay, so let's go ahead and get the relative frequency. How do we do that? We just divide and turn our fraction into a decimal. Okay, so we have our 580 divided by 2,000, simplified, turned into a decimal, all that jazz, and we have 0.29 as our relative frequency, okay, which is 29%, okay, of the DVDs were comedy. But we're going to keep it a decimal to do the math work because we don't use percents to do math work. Okay, so let's go ahead and set up your proportion because we want to predict the 5,000 instead. Okay, so we have 0.29 for 1. Okay, so when we simplify this out, okay, we have 0.29 comedy, okay, for 1 sold, really, instead of 2,000 sold, okay. It doesn't really make too much sense that way, but that's a unit, how the unit rate would be. And then let's go ahead and predict the 5,000. Okay, technically you don't really even need to come up with this unit rate. You could just use this instead. It still would work the same thing because it's a ratio. We just have a equivalent fraction. And then we want to know how many comedy, so we can just use C again, and there we go. All right, so let's go ahead and we can multiply by 5,000 over 5,000 to create the equivalent fraction. Okay, and so 5,000 times 0.29, and there we go, 1450. Okay, so we have 1,450 comedy DVDs. Okay, and there you go. So that's how many comedy DVDs. Okay, now there is another question. How much profit can she expect to make? She makes $3.31 profit on each one. So we need to go ahead and multiply that, okay, by $3.31. And let's figure out what our profit is. Okay, so 331. So let's go ahead and take the answer times 3.31, and we have, ooh, that's a pretty good profit. 4799.5. 4799.5. It's money, so 0.50. And we have a $4,799.50 profit just on those comedy DVDs. So pretty good deal. All right, let's go ahead and try this one out. Good one to pause and see how you do. So a local pizza shop sold 100 pizzas last week. The number of each type of pizza sold is shown in the table. The store makes $5.15 profit, so that's good information to get, on each sausage pizza based on the relative frequency. So the good thing is they gave us our frequency already. How much profit can they expect to make on sausage pizzas next month if they plan to sell this many pizzas in that month? Okay, so we have to figure out how many total pizzas they sold this month, okay? But guess what? They already tell us up here. They sold 100 pizzas, okay? All right, so we're only focusing on sausage, which is 28, okay? So we know they sold 28 sausage out of 100. Now, we could simplify that, but really we know about proportions, and that is a ratio also, and we can use that ratio to predict with a proportion what it would be if we changed it to 525, okay, by creating an equivalent fraction here, okay? So the only thing is, it makes it, you have to cross multiply. You're not going to be able to visually just see this easy equivalent fraction problem. Okay, so let's go ahead and see how many sausage. We'll do an S for sausage. I'm going to go ahead and cross multiply. So I have 100S. So it's a good review on proportions, equals, and then 28 times 525 is 14,700. And then we can go ahead and isolate that variable, divide by 100, divide by 100, cross that out. Dividing by 100, this is easy though, moves 2 swoops to the left, and that gets us the amount of sausage is 147 sausage. Okay, and so there we go. We can expect to sell 147 sausage. They want to know how much profit, if they make 515 in profit, so let's multiply by 515. And let's see, 147 times 515, and we get 757.05. 757.05 profit. And there we go, done. Okay, all right, let's go ahead and head to the homework now for this 9-2 practice. Okay, so it's going to give you a lot of experience with everything we just did, with including one apply. Let's take a look at that apply right away first. Here's the table that shows the number of each type of snack bag that was sold this month. So let's see, did they tell you how many sold total? The school makes profit, expects to sell next month. Nope, you're going to have to figure out that total. So what's the total from this month so we can get our denominator? Okay, and then there's your denominator. We're focusing on which snack bag, though. Let's see. They want you, based on last month's result, how much can the school expect to make on potato chips? So we only care about this number out of the total, and then set up your proportion, okay, to help us predict what we would sell if we sold 1,200 bags. And then with that profit, tell us how much profit we would make with that new result. Okay, so take a look at the notes if you need a reminder of how to do that. Okay, all right, let's jump back up to the top. We got some spinners here and things like that. We're just focusing on relative frequency. Remember, that's just sharing the fraction, decimal, and percent, please. But you're not talking about probability of different things happening. Okay, so a spinner with 4 equal sections of blue, green, yellow, and red is spun 100 times. So that's your denominator. Okay, and it lands on blue 14 times, green, blah, 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 blah. What's the relative frequency of landing on red? And what's the relative frequency of landing on green? So be aware, it's not red or green. They want you to do the problem with red, and they want you to answer for just green. So if I'm just doing red, I'm only looking at red, and red landed 68 times out of 100. I know that's 6,800, 0.68. I know that's 68%. So you're going to do that for green as well to solve that one. Okay. All right. Frequency table shows the results about favorite exhibits. Find the relative frequency. Okay. That the favorite exhibit was either butterfly or trains. Okay. And they want you to share that as a percent. You might as well do fraction, decimal, and then make sure you do percent at the end. So remember, butterfly or trains means you're adding butterfly and trains together, okay, to figure that one out, okay? All right, take a look at number 3. The graph shows the results of an experiment in which a number cube labeled 1 through 6 is rolled a number of times. What is the relative frequency of rolling a number greater than 3? Okay, so greater than 3 means we have the 9 plus the 5 plus the 12. okay, out of how many total rolls? Okay, so we're adding up 9 plus 5 plus 12 over the whole grand total and figure out that relative frequency of fraction, decimal, and percent. Okay, all right, so now this one for number 4, they've already given you the relative frequencies. Okay, so remember, this one's not going to be out of anything, but I do want you, because they're asking what is the experimental probability of a student receiving gift card money, I want you to write the probability of card or money. Okay, and then list what that probability is as a fraction, decimal, and percent. Okay, all right, so if you take a look at that, we're looking at card or money. Remember, for these ones, you're just adding these up. Okay, these are already in percent form, because remember, we have 45% and we have 35%. Okay, it's already in percent form. So what is the total percent probability? Okay, so that should be an easy one to add up. And then number 5, based on previous orders, the manager of an ice cream shop determines the probability the customer will order chocolate is 85%. Okay, if there are 240 sundaes ordered in 1 week, how many are expected to be ordered with chocolate sauce? Okay, so this one brings us back a little bit to, they're giving you that relative frequency, that 85%. How would you write that as a fraction? Well, you could write 0.85 over 1, okay, to make that proportion, or this would be 85% is 85 over 100, right? That's what 85% is. And they want you to predict, well, what is the chocolate sauce situation, because the 85 is the chocolate sauce, if there were 240 sundaes, okay, instead of 100, okay? So you can go ahead and solve that, and we want to figure out how many of those sundaes would be C, or chocolate sauce. So there you go. Go ahead and work on that, and then let me know if you have any questions.